Parallel algorithm assessment usage of images segmentation quality in medicine. There is an increase in medicine data quantity and image resolution requirements due to the modern medicine development, which leads to necessity of strong computing resources and high computer memory amount during the appropriate task modeling. Semantic segmentation in medicine implements assessment function in diagnostics. Modern medicine needs technological solutions that are going to help doctors to diagnose the patients. Biomedical images play an important role because they visualize internal structure of the human body's objectives, which allow determining the course of diseases or early stage of diseases such as cancer and others that cannot be determined by the human. The aim of the research is to study the effectiveness of parallel algorithm for biomedical image segmentation methods, namely the Vinegar methods, Sobel's filter, and Canny age detectors. The research objects are a process of the biomedical semantic segmentation of images using artificial intelligence methods and the efficiency of the segmentation methods parallelization on the graphic processors. The research subjects are methods and machine learning tools for semantic segmentation of medical images methods and segmentation algorithm parallelization tools on graphic processors. The tasks of the study can be divided into the following stages: subject area analysis, design and information systems, and CUDA technology research. The system developed in the work consists of several components that can be narrowed down to two main ones. The first is segmentation using the OSU methods, the Sobel filter, and the Canny boundary detector. The second component is a semantic segmentation, which is implemented using the unit architecture. The main idea of all two methods is to find a threshold value that will minimize the variance within the class. Importantly, minimizing variance with one of the classes is the same as maximizing interclass variance. Generalized algorithm. Calculate the histogram and probability of each investee level. Set initial approximations. Passing all possible thresholds value and maximal values. The Sobel filter is a method of age detection that uses gradients. The Sobel filter works by calculating the image intensity gradient to each pixel within the image. It finds the directions of greatest increase from light to dark and the rate of change in these directions. This age selection algorithm is also a gradient method and consists of 5 steps. The first one is apply a Gaussian filters. The second, find the intensified gradient Sobel filter. The third one is apply non-maximum separations. The fourth, apply a double threshold. And the fifth, trace the ages with hysteresis. Non-maximum supersessions is a technique of thinning the age which is used to find place with the sharpest changes in intensity. Algorithm of each pixel on the gradient image. Comparison of the force of the current pixel age with the pixel force level in the positive and negative direction of the gradient. If the age trend level of the current pixel is the highest compared to other pixels with the same directions. The previous filters have been applied to the image to detect true ages, but there may still be noise or false ages along to the age. The two shareholds filters using hide and loves thresholds in the image to identify strength and weakness. If the pixel value is greater than the height threshold, it's marked as a strong edge. If the pixel value is less than the upper threshold but greater than the low threshold, it's marked as a weak edge. And if the pixel value is less than a low threshold, the pixels is completely discarded. In addition to detecting boundaries of 4 previous filters have filtered out the noise that was present in the image, because there may be some edges that have been very heavily filtered. The hysteresis filter make one last pass over the image and connect the edges that should have been connected. Semantic segmentation is the task of clustering parts of an image that belong to the same class of objects. It can be considered a prediction at the pixel level, because each pixel in the image is classified according to class. The algorithm can be described by the following steps. Step 1. Initialization of all filters and parameters, scaled by random values. Step 2. The network takes the training image at the input passes in all layers and at the output gets the probability for each of the classes. Step 3. Calculate the total error on the source layers. Step 4. Use the error back propagations methods to calculate the error gradient for all weight in the network, and use the gradient descent to update all parameters and weight to minimize the original error. Step 5. Repeat steps 2, 3, and 4 for all the images in training set. As a result, the main functionality of the information system is given in so there are such main functionality of the information system, such as working with the data, image processing, neural network training for semantic segmentations, also method, Sobel filter, and Canny boundary detector. Table 2 presents the results and comparative characteristics of serial and parallel also algorithm. Table 3 presents results and comparative characteristics of serial and parallel Sobel filter algorithm. Table 4 presents the results and comparative characteristics of the sequential and parallel algorithm of the Canny boundary detector. Figure 1 shows a graph of changes in a value of segmentation estimations according to each approach of neural network training. Table 5 presents a comparative characteristics of serial and parallel algorithm unit neural network training. Figure 2 shows an example of performing semantic segmentation using a neural network. Figure 3 shows reference segmentation for experimental imaging. Image segmentation in medicine is a challenge that needs new and better solutions over time. It's relevant because it helps to identify the basic structure of the human body with the help of images that represent them, which increase the accuracy and speed of diagnosis and reduces the risk to human life and health. The number of biomedical images is constantly growing. The size and resolutions of such images is also increasing. This leads to the need for large computing and hardware resources if you use sequential algorithm. This problem can be solved or minimized by using parallel algorithm on GPU.